Hello guys, in this tutorial I will explain how to make UV coordinates for simple curve objects created in geometry nodes. If you haven't used in Blender for a while, it's almost sure that you already know how to make some simple tubular mesh. You only add a new curve, go to the Object Data Properties, open the Geometry menu, and change the dip value in the Bevel menu. One of the advantages that come with this method is that if you want to apply a texture to the mesh that the curve created, this object already have a UV map. Then, when you're trying to do the same, within geometry nodes, because you want it to look fancy, the moment you apply your material, nothing happens. And after a time investigating what is the problem, you realize the UV coordinates don't work. Then you ask, "Hey Blender, where's my UV map? Is right there? Oh really? Then show me the UV map." Okay, I will. Oh, you have to make it yourself. Oh god. For the people who only want to know the node setup, I will show you a screenshot and give a quick explanation about how this works. And after that, I will explain everything in more detail. In geometry nodes, when you transform a curve to mesh, usually you connect a curved circle in profile curve, but instead you have to connect a curved spiral. Rotations need to be 1, change the height value to 0, and you control the radius by connecting an input value node in start and end radius. Then, connect a capture attribute node in both curves before you transform them to a mesh, and connect the factor from a spline parameter node into the value of both capture attribute nodes. Add a combined XYZ node, connect the output attribute of the curve in the X value, and the attribute of the profile curve in the Y value. Add a store named attribute node after the curve to mesh node, change the data type to vector and the domain to face corner. Connect the vector output of the combined XYZ node in the input value and write a name for the attribute. I will name mine New UV. Add a set material node. If you already have a material for the curve, select it in the list, and finally add a mesh path distance node. In your material, you only have to change the UV coordinates for an attribute node, write the name of the attribute, and connect the vector output to your texture. And lastly, if you want to export the mesh with your UV map, you only need to right-click your object, convert to mesh, go to the Object Data Properties, in the Attributes tab, select the one that contains your UV map, click Attribute Specials, Convert Attribute, change mode to UV Map, press OK, and now if you check the UV Maps tab, you can see the UV map with the name you selected for your attribute. If you're still here, that means that you want to know how is that all of this works, and why I'm using the nodes that I just showed. So I will explain everything in more detail, starting with how a UV map works. A UV map is nothing more than two-dimensional coordinates with x and y values that go from 0 to 1, and this determines the position of the texture that we project into the 3D model. Geometry nodes have an unwrapped node, but the result is different from what we want to recreate. That's why we need to make the UV map in a different way. Fortunately, the UV map we're trying to make is really simple. It goes from 0 to 1 in both axes and follows the shape of the curve. Now, if my explanation of how a UV map works is correct, that means we need to get x and y values from our mesh. We can do this using the factor from the spline parameter node. This gives a different value to each point of the curve, going from 0 for the starting point to 1 for the last point. We use the capture attribute node to get the float value from each point, then use the combined XYZ node to transform the float values to vector, leaving the Z value in 0 because UV maps don't use it. Save this information in a new attribute using the store named attribute node, connected after we transform the curve to mesh, with data type as vector and domain as face corner, because the UV map information is saved in the corners of the faces in the mesh. Now, the first question is, why we use a spiral instead of a circle in the profile curve? Well, this is easier to explain using a low resolution circle. I will use one with a resolution of 5. The first thing to understand is that every time you create a curve with a closed shape, it means it's a cyclic curve. The big difference between a cyclic curve and a normal one is that the cyclic one connects the last point to the first point. If you remember, the factor gives every point a different value from 0 to 1. So, when we use a cyclic curve to create a mesh, every face has values depending on their vertices, which means that the faces that are created between the first and the last point have values that go from 1 to 0. So, what we actually need is a non-cyclic curve that creates a new last point in the same position as the first point. That way, every face will have the correct value. And of all the things that I tried, the easiest way to create a circle with these characteristics is with the spiral node. Now, the last question is, why we use the merge by distance node? The answer is really simple. Because we use a spiral node, even though the last and first points have the same position, they are not actually connected. Every time we have a mesh with smooth faces, and some of that faces are not connected, it shows in the render by breaking the smooth transition. So, to avoid this, the node merges all the vertices that are close enough to each other. While using this node, it shows why it's important to store information in the correct domain when we create a new attribute. Because if you store the UV map data in the wrong domain, for example, point instead of face corner, it breaks the UV map. Because when we merge the vertices, it creates new ones that don't contain UV information, so Blender does what it can with the data that is left in the other vertices. Well, that was all for this tutorial. Please subscribe if you want to know when the next one will be uploaded, and if you have any questions or suggestions for what the next tutorial should be, please leave a comment. Take care and see you later.